Okay, we're on page 2 now. And this first one has a GCF of 3, doesn't it? We factor out a 3, we'll have x to the 4th minus 16 y to the 4th. This is the square of x squared. This is the square of 4y squared. So I'll continue on down here. I can write x squared minus 4y squared, x squared plus 4y squared. So that's the factoring for x to the 4th minus 16y to the 4th. And this is another difference of squares. This is a sum of squares, so that's fully cooked. No further steps with that. But this is the square of x minus the square of 2y. X and 2y. X and 2y. Make one of them minus, the other one plus. Don't lose that piece. Oh, be careful. There's our complete factorization for number 7. Okay. And for number 8, I see a GCF of 5. 5 times x squared minus 16 w squared. It's 2 terms. It's a square minus a square, so we can say that's the square of x. That's the square of 4w. I write 5 x minus 4w x plus 4w. That's the end of that. There's 3 terms, and I could go right to the AC method and make a hell of a mess, because that would make 900. I could factor out a 3 though. 3 times x squared plus 20x plus 100. And I could say 2 numbers that add up to 20 and multiply out to 10, or 10 and 10. So x plus 10, x plus 10. Or I could look at it as that's the square of x, that's the square of 10. And if you do 10 times x, you get 10x, and if you double it, you do get exactly 20x. So I could also see this as a perfect square trinomial. Either way, the answer is the same. It's 3 times, I could write x plus 10 squared, but I'll write it out x plus 10, x plus 10. Same factor appears twice. Now we're up to number 11. And there's no GCF. There's 2 terms. It's not a sum of cubes. That's the square of 3x. That's the square of 7. But it's a sum of squares, and so it does not factor. And we call that a prime polynomial. Terribly useful in real life. Used a lot in like ATM machines and making encrypted websites. Anything where there's a need for codes, credit card numbers, all that sort of stuff. You might jump in here and do 4 times 36, but that would make an unnecessary extra bunch of steps. Everything is divisible by 4. We have a GCF of 4. 4 times x squared minus 6x plus 9. And I can consider this as a perfect square trinomial, because that's the square of x, that's the square of 3. 3 times x is 3x, and 2 times 3x is 6x. It's minus 6x, so we make it minus instead. X minus 3, x minus 3. Now, if you didn't like that approach, remember, you could also just say, what are 2 numbers that multiply out to 9 and add up to negative 6? And it would be a negative 3 and a negative 3. You get the same final answer. Okay? And now we're right here. Is there a GCF? Is there a GCF? Certainly an x and a 3. So I'll write 3x, 8x squared minus 22x plus 5. Okay? Excuse me, sorry. Now that's not the square of something, neither is that, so we're not going to do perfect square trinomial. We're going to do the AC method. 8 times 5 is 40. And if I do 2 times 20, 2 times 20 is 40, 2 plus 20 is 22. I need minus 22 in the middle. Not a problem. That's still going to multiply out the plus 40, but now that'll add up to negative 22. So I go to this little rewrite step. I'm going to use a square bracket just to make it easier to read. Instead of minus 22x, I'm going to write minus 2x minus 20x, and then plus 5. And now grouping like so. Common factor here would be 2x times 4x minus 1. Common factor here, I'm going to say a minus 5 times 4x, and I want a minus 1 to replace that plus 5. And now I got that common factor there, so it's 3x, 4x minus 1, 2x minus 5. Please, please, please notice the signs, the minus there and the minus there, and notice the parentheses. All that stuff is important. What's not important anymore are these brackets. If you leave them there, it's not wrong, but it's in bad taste. You really want to get rid of them now. Just write 3x, 4x minus 1, 2x minus 5. If you got this order, rotate, that's fine. It's this times this times this, so any order is okay. That takes care of page 2.